In this example, I'm going to take this integral. One thing about this, when I look at this function right now, I'm going to want to take the antiderivative of that. I don't like the fact that this is a quotient. I've got a function in the top and a function in the bottom. So I'm going to have to try to rewrite that. And what I can do is split it into two fractions with that common denominator of r to the fourth. So this would be r to the seventh over r to the fourth minus r to the fourth over r to the fourth dr. Then we can just simplify those separately. 7 minus 4 is 3. R to the fourth over r to the fourth is just 1. Now I can take the antiderivative. To do the antiderivative, well, derivatives, I would bring this down in front and subtract 1. Antiderivatives, I have to add 1. And then we have to divide by that new exponent. Because then if I took the derivative, this 4 would come down and cancel, and I'd go back to that up there. The antiderivative of a constant, I just add on an r in this case. That's my variable. So I wrote a 1. I'm not going to have to leave that 1 there. So what I'm going to get then, I'm going to plug in my 5 to the fourth over 4 minus 5. And then I'm going to plug in the 4. 4 to the fourth over 4 minus 4. So 5, 25, 125, 625 over 4 minus 5. 4, 16, 64, 256 over 4 minus 4. So 625 over 4 minus 5. 256 over 4 is 64. Minus a negative 4 becomes plus 4. So I get 625 over 4 minus 5 plus 4, negative 1 minus 64 gives me negative 65. I'm going to want to think of that as over 1 so that I can get a common denominator. So 625 over 4. 4 times 65 is 260. And so I get 365 over 4.